All right, everybody who wants to break and enter, this is definitely the good place to do it. Well, I mean, try not to break too much. We need it to run. That would be great. Our next speaker is all ready to go. This is Nick Delewski. He is the managing consultant and penetration tester with Spirent. And more importantly, he got approved because this talk just sounded way too much fun. Who here knew about the SimpliSafe SDR hacks last year-ish? Yeah, well, he's apparently got the whole thing just worked out in the funniest possible way. So, Failsafe, yet another SimpliSafe attack vector because apparently it wasn't bad enough. So, please welcome Nick. Thank you.
How's it going, everyone? I'd like to just start off with a thank you to the Wireless Village for giving me the opportunity to speak today. I have to say I'm a bit humbled to be right in between two individuals who design software-defined radios for a living. So this talk sort of takes a different tack toward the SimpliSafe vulnerabilities that were discovered before. We'll get to a little bit of the history in a little bit. A little bit about me. My name is Nick Delewski. You know, for the last name, there's only one letter that you don't pronounce, which is not bad for a Polish name. As was said, I'm managing consultant for Spirent Security Labs. My specialization is actually in network pen testing, and I wanted to sort of do this talk to document a little bit about how I went about, trying to broaden horizons a little bit and go beyond just the network pen test, but also taking a look at the general methodology I used and sort of how I applied that same methodology to learning some new skills. I have 5+ years of pen testing experience. Prior to that, I have a little over 6 years of security analysis and systems admin experience. So with that being said, there's obviously the obligatory meme slide here. Everybody at home who asks what I do, my friends think that I'm, from hackers. My family are convinced that I work for 3-letter agencies. TV producers have a laughable concept of what network penetration testers do. Just random people on the street think that, absolutely everything that you see on Mr. Robot is real. Some days I think that, all I'm doing is collecting shells, but what I actually do is just drink way too much coffee and do my job. So a little bit of fair warning. In my experience, as you can see, I come from a systems administration background. I was never a developer. I learned Python through my experience with other scripting languages. I'm not going to be releasing full or finalized code today. For a couple of reasons. I will, however, be hitting the highlights of some of the milestones that I had reached along the way, talking about some of the libraries I used to create the scripts that I used, and talking about the process. Finally, I'm a sysadmin. It's ugly code anyway. I'm sure that if there are developers in the room, you could do it yourself and do it in a way cleaner way than I did. So when we're talking about anything that has multiple components that interact with one another, you're still dealing with some form of a networked system. So the user still has to interact with the system. The system components all still have to interact with one another. Now, the mechanisms for this, not necessarily, they don't look anything like what we're necessarily used to in the traditional client-server model with laptops and enterprise applications. However, we can still look at them mostly in the same way. Now, when I am trying to reverse engineer a system, I generally start with the techniques that I'm most familiar with, and that familiarity means that I know, what those techniques are good at and also where the blind spots are. And I kind of start with the most familiar so that I know that I can get those out of the way early. And then I can use my time wisely and learn more skills along the way. And that's honestly my goal with every project or every research project that I do. So when we are doing reverse engineering, essentially we're performing experimentation over and over again. We're taking stock of what we can infer based on what we know, and we're also taking a look at how can we apply that knowledge to control the system. And once we have a little bit of control, we're going to go in a constant loop to see what else we can learn with that control and reassess and reevaluate. So there are a lot of different organizations out there that have penetration testing frameworks. This is one that I kind of go by when I'm dealing with a specific system as I'm trying to develop an attack or an exploit. I use some different ones when I'm actually dealing with full networks and things like that. But in general, you've got four main phases of it: open source intelligence, passive recon, active testing, and then weaponizing. So for open source intel, we do have a lot of previous research that's already been done on the SimpliSafe system, and I'm going to talk a little bit about that in a few minutes. I've also got, obviously, the FCC filings on the device. We've got setup guides, and we've got help forums. For the passive recon, just in general terms, I like to think of passive recon as something that I can do that doesn't directly interface or interact or change the environment, or at least not meant to. So you set up the monitor, and then you perform regular non-malicious tasks, just looking at seeing the activity and trying to tease out what you can for later analysis. Now, when you're ready for active testing, you're making controlled changes and looking for differences. You're observing and comparing responses, and then you're sort of building up some automations to further that process. And finally, we're coming to weaponizing, where we're going to collect and synthesize everything that we have done over the past three phases. Then we're going to perform our tests, where we're actually testing out our hypotheses about how the system works. We're extending those tests based on new information that comes in, and then we are refining our knowledge and filling in the gaps that we have. Finally, we're going to take the tests and the exploits that we've already mostly written. We're going to automate it to save time, and we're going to optimize it for whatever our attack scenario is. The final bullet point there, deploy and exploit. We would do that on a real-world penetration test. Because this is more of a lab exercise, it's not so much of a big deal, not so applicable, so just like to mention it sort of as a reference. So taking a look at the system components of a SimpliSafe system, there are three components that I classify as user interface components. That is the base station, so this road cone looking thing up here. There's a keychain remote. Well, the remnants of it are up here. If anybody wants to see this after the talk, feel free to come up. And then you have the sensors that will hopefully send an alarm to the base station for processing. So the previous research on this, first research that I found on it was done by Andrew Sonnenberg. I believe it was with IOActive, sent in February 2016 using a replay attack by interfacing the SimpliSafe keypad with a microcontroller. So sort of taking the SimpliSafe hardware just for the radio circuits so that there didn't need to be any reverse engineering on that side of things. And the way I understand it, he was using the packets that were coming in from that radio hardware, decoding them, and then replaying and manipulating as necessary. A couple of days later, Michael Osman, who I believe is actually speaking after me, and I'd love to get his take on what was found here. So he exploited the vulnerability by capturing and decoding packets with SDR and Yardstick 1. That way, you didn't even have to use any SimpliSafe hardware at all to perform the attacks. So while that vulnerability in that information was, as far as I've done in my research, well received in the information security community. If you take a look at some of the user forums and some of the other feedback, one of the criticisms was that, well, these are people who are clearly experts in the field. They're on the cutting edge. Would an attacker be able to exploit these without advanced degrees in electrical engineering? Just philosophically speaking, I think that we as security researchers kind of need to be on the cutting edge and letting manufacturers know, hey, this is a problem, so that way they can design their systems to withstand conditions that will occur into the future. So these days, kids are being taught in grade school basic programming skills, and those programming skills are being applied to things like microcontrollers. SDR I'm seeing pop up in things like youth library programs. People are learning about radio, and it's a great thing. Technology is surrounding us, and it's not going back the other way. But the fact remains is that the threat landscape has certainly changed a lot over the last 10 years and will continue to change in the future. So I don't agree with the assessment that, hey, just because it requires advanced knowledge in the field to be able to to exploit these attacks, it's not really a flaw. I believe it absolutely is a flaw. It needs to be fixed. But what I'm going to do in today's talk is demonstrate the vulnerability which is inherent to the security architecture without requiring either SDR or hardware modification. I am going to take SimpliSafe's hardware and basically use it against them. So one of the components of the system that wasn't directly analyzed in the research that I found was the keychain remote. Now, the keychain remote goes beyond what you would see for your car or even some other home security systems. It actually has USB functionality built into it. And what that USB functionality does is it basically presents a virtual CD-ROM drive to the operating system, and then there's an application and user interface on there that allows the user to make changes to the system, and then it's synchronized back to the base station by this USB port up here at the top. So that interface is programmed in Shockwave Adobe Shockwave. And so I realized that it might have been a little bit faster to, say, use a Flash decompiler, go that route. But again, not really a developer, sysadmin, going from things that are quick and easy, working my way down to things that I need to maybe do a little bit more work on. So like you would expect with the keychain remote, it does have the arm and disarm functionality. So there are a couple of risks when taking a look at this little piece of hardware right here. First thing that came to my mind is loss or theft. So what happens if somebody gets a hold of this? It's got a full copy of the system's configuration on it. So when I went through, and this is just a little quick screenshot of the interface here. When I went through some of my open source recon, I saw some guidance originally that said, oh, well, I lost my keychain remote, and so what do I need to do to make sure I'm still secure? So originally the guidance was all you have to do is just remove the remote from your system. Nobody will be able to arm or disarm your system. It'll be okay. Just we'll send you a replacement. It's all good. But that configuration being on the remote really didn't sit well with me. So I continued to extend and take a look at that component specifically. So I went out and I bought a SimpliSafe system. I bought one of the basic packages. It comes with the base station, keychain remote, keypad, 4 entry sensors, and a motion sensor. So it's a good cross-section of sensors. It's a reasonable system that you would expect people to be able to deploy in a small office, home office environment, or in a normal residential environment. Doing my open source recon, I did note some interesting things about the FCC filings themselves, namely that many of the FCC filings go all the way back to November of 2008. So, as I said, the threat landscape has changed significantly in the past 10 years, as you would expect it to. In the defense of SimpliSafe, this hardware is quite a few years old. I think that the industry as a whole has done a lot of learning since then. So, kind of following on from that a little bit, I didn't really get too far into in-depth with the internal photos and looking at the hardware chips and looking up individual chips on the devices because, again, not really my goal. I wanted to see what we could do with the hardware, the system as it was unmodified. So taking a look at tools that I would use to analyze any USB device, I kind of did a little bit of brainstorming here. We've got ProcMon, which is a former sysinternals tool before Microsoft bought sysinternals, useful for all kinds of operating system level monitoring of inputs and outputs on the system. Wireshark has functionality through USBMon, so that would let me see the traffic going from the web application interface back down to the physical device itself. Python, also always a pen tester's friend, has a library PyUSB, which appears to be a C-types wrapper for libUSB. Also, you can't forget, and I do have to credit Google and Stack Exchange for all of the research that I did on there as I was trying to learn a little bit more about USB at a low level and how to interact with it with PyUSB. I'd like to say that you can use your OS of choice here. Just because I chose to do this research and development on a Linux box doesn't mean you couldn't use a Windows box, doesn't mean you couldn't use a Mac OS device. The USB keychain remote itself doesn't actually support Mac OS, so I think that Windows was the most convenient for that part of it, and so I kind of went a hybrid route between Windows and Linux for it. eBay, again, will become useful for reasons apparent later on in the talk, and of course, a little bit of caffeine on a cold, snowy afternoon. So taking a look with ProcMon, which I would figure would be the best place to look for file activity related to configuration changes, actually showed lots of activity, but it didn't show any writes at all. It's not that surprising since there was a CD drive that was being presented by the USB remote as you plug it into the system. So in that regard, that was a good way to confirm kind of what we're looking for, but not really useful to us for furthering our access. After that, what I decided to do is I decided to take a quick image of the drive as it was presented to the operating system using DCF-LDD. DCF-LDD is basically a forensic version of the basic DD imaging utility. So I took a before image, and then I made a couple of changes in the configuration. I took an after image, and then I diffed those images. Did not find any changes at all on them. So, okay, pretty confident nothing is happening with that presented CD drive. So after that, I go on to Wireshark and USBMon. So this is what a typical read access would look like. And again, I apologize if the text is a little bit small. What it shows is a SCSI read with an opcode in the parentheses there of 10. So again, it's well understood by Wireshark. It's easily parsed, not likely to be anything too far out of the ordinary. What I also found, though, as I was taking a look at the traffic, was that there were some other opcodes that Wireshark couldn't decode. And the one interesting one that I really keyed in on was the opcode F6. So as I was taking a look at these F6 opcodes, I did see that the packet lengths were changing a little bit. So going through and doing a little bit more analysis, here's another F6 opcode where a couple of packets down, you see the URB bulk in, the length was 576 on that, as opposed to the previous one where the length stayed within the double digits. Taking a look at that bigger packet, I start to see some interesting information. Namely, what I see is I see the ASCII serial numbers of some of the devices that are in my system. So what I have is I have the whole configuration in that little 576 byte packet retrieved and saved in plain text. As I was taking a look at the packet, you could see that no authentication methods were used between the host computer and the keychain, and the authentication that occurs between the user and the keychain, where you would ordinarily have to put in your master PIN that you had previously defined, is easily bypassable, because in order to check to see if the passcode, if the PIN you put in is correct, the application which is running on the laptop needs a copy of the full configuration. So the authentication there certainly has some problems. So interestingly, I noted that all of the disarm codes for the system were in plain text. And even better than in plain text, they treated the hexadecimal nibbles as though they were a full character. So if you took a look at the hex of the packet, a disarm code of 9999 would actually show up as 9999. It wasn't even encoded as an integer where you had to do some decoding, or it wasn't base 64 or anything like that. So it couldn't get any easier to see the codes. I obtained the serial numbers of all devices on the system except for the base station. And that's significant for a couple of reasons that I'll get into a little bit later. So the next step is going to be to break down the unknown parts of the configuration. My goal here is to identify as much as I can about the device types, the different modes and options for those devices, and also the global settings. Another key observation is that the configuration is always a constant size. No matter how long the strings are that you put into the UI for the serial numbers as you're adding new sensors, the configuration is always a constant 512 bytes. And that makes diffing a lot easier for us. We know that we're going one-to-one. We don't have to account for changes in address space. If I make a change, it's going to change a finite number of bytes in the configuration. And so I can tell exactly which bytes were affected immediately. It also brings up the prospect of possible buffer overflow in other parts of the system, although that wasn't really what I wanted to go for today, so I didn't test for it. Maybe another day. So this is where we start our analysis and are making our control changes. Go through and we make our control changes in the UI. We compare our data to what we previously saw, and then we just wash, rinse, repeat as much as we can, as fast as we can. So in order to automate that process a little bit, because even in a small system like this, there are quite a few variables in terms of the sensors and the actual global settings themselves. I turned to PyUSB. Python, again, being a fairly robust language, there's usually libraries out there to do the bulk of what you want to do. So I wrote a little script to go through and get all the information that PyUSB can off of a device. So the device itself is fairly basic. And in order to start off, you need to know which device you're actually going to query. Simplest way to do that on a Unix command line, you're going to do an ls of the USB. I just happen to redirect that into a file called USBMon. You plug in the physical keychain remote, pipe that output to USB 2, and then a simple diff USB 1, USB 2 leaves me with the string right there. So this is just a quick PyUSB script that'll go through. It will detect if there is a SimpliSafe keychain remote that is attached to the system, and it's going to print everything that it knows about that device. If it doesn't find the device, it'll print a little sad face. So, all right, we know that we can interface with the device as it is on the typical Unix, Linux machine. As noted before in one of the previous slides, it's a simple device that only has one configuration, and when you're talking USB, you kind of have a hierarchy where at the top level you have the device, down below that you have the device configuration, below that you have interfaces, and on an interface you could have a couple of different endpoints. So there's only one configuration, there's one interface, and I believe 2 different endpoints. Couldn't get much simpler than that. Interestingly enough, if you just start querying some of the other devices that are on your system, or any other random USB gadget you have, you can find some pretty interesting stuff out about your hardware you just have sitting around with very little effort. So here's how we start out. We actually use PyUSB to connect to the endpoints on the USB drive. So EPO is the output endpoint. So that Lambda function there will basically just help PyUSB go through and query for the first one available. I believe that you can actually hard code those endpoint numbers as well. I just happen to use this. And again, this is code that was borrowed from Stack Exchange, so it is what it is. So this one here contains really what's important for the analysis that we're going to be doing. For the sake of speed and for the sake of being easy, I decided to go the replay attack route instead of trying to go through and decode those custom opcodes. I didn't want to risk bricking the device because that would get expensive eventually. And also, if you know something works when you're early in the analysis period, get what you need to out of it first, and then maybe you can afford to be a little bit more exotic with your attacks. So I did take the bytes from the commands to get the configuration from the USB remote. I also took the bytes from the request to set the data, write it back to the remote, and also there appears to be a reset packet that gets sent in order to make sure that multiple writes and multiple reads are handled by that interface application. So I also captured those bytes as well. Never did get the reset packet to work, which is part of the reason why I'm not releasing any code. So one of those things that I can work on another day. So you put the blob into the replay, and you set with the EPO.write routine there, send the request to get the data, then you have to read the data in from the buffer. What I found is that the timings were sometimes a little bit inconsistent when I was trying to access it through PyUSB, so I did write a little try block there, which will somewhat handle the timeout operations. And what you get back is you get back the raw config data as a Python list. So now we're just going through and we're mapping GUI elements to configuration addresses. For the globals, what I found is that they put the global configs in the first part of the packet, and then you've got the pins, which, by the way, again, it's all the pins plus the duress pin as well. If somebody were looking to play a really cruel joke, they could switch the duress pin with the master pin, and bad things would happen. Again, that's something that really emphasizes the need to lock down all these different interfaces. It's not just a trivial thing, and actually sort of you kind of wonder why the functionality was built into the remote in the first place, given that somebody's going to carry this around everywhere, you could easily lose it. Personally, I think that this information would have been better handled by providing an application that generates the configuration, puts it on a USB stick, and that way you know that configuration is on that USB stick. You can lock it away, you can keep it wherever you want. You don't need to carry it around all the time in order to use why the device was built, which is as a remote control. So after going through all of the different configuration settings in the GUI, which include things like alarm volume, whether or not there are any lights that are activated at any point, the alarm signal duration, so that's the amount of time that you have to get to the keypad and put in the PIN before the alarm goes off. It also includes things like whether the voice chime is on, whether the chime functionality is on, which dings when a sensor is activated. So all that stuff is now mapped out. In addition, the different sensors have an option block which do different things depending on the sensor as well. So for an entry sensor, you could have a configuration where the sensor is only active when the alarm is armed in away mode, which for those not familiar with home alarm systems, generally they can be armed in home away or home at home. That way you're not, you're disabling certain sensors while you're still in your house, so that way you're not tripping your system every time you want to go down to the basement or every time your dog runs by the motion sensor. So a little while later, after I go through with some automation, some scripting to identify the addresses, what goes where, we have a little bit of a better idea of what serial numbers are matched to which device. I spat out the data as some ASCII config, just kind of for reference and to give a little bit of scale on how big that configuration actually is. As you can see, I was able to easily parse out the volume, whether the door chime was active, and all the different pins broken out by number and function. So now that we have a significant amount of information about how the system actually works, we're going to ask ourselves, what in total do we know about the system at this point? So we know that adding sensors to the system only requires a serial number based on what we've seen from the GUI. In addition, we know that communications are susceptible to replay attacks from the previous work that was done by Andrew Zonenberg and Michael Osman. So what's our hypothesis here? The sensor doesn't likely authenticate to the base station because it's just broadcasting simple packets out to anybody who will listen. So the sensor types and numbers are contained in the configuration data, and a sensor is configurable in a separate base station. The hypothesis here, rather, is that the sensor can be configured in a separate base station based on a config that's stolen from a USB stick. Also, it's noted in the documentation that the sensor range is about 100 feet from the base station, and given that sensors are often placed on the perimeter of a protected area, on the windows, the doors, it's pretty likely that there's going to be over-penetration out to public areas or areas that you're not really able to physically control so much. So taking our three sub-hypotheses, the hypothetical attack that we're going to work on is that a stock base station can be configured with sensor values from a stolen configuration, and then an arbitrary malicious base station can receive and interpret those sensor signals. What's the next step? It's going to be to source another base station and test out our hypothesis. So for that, I turned to eBay. I didn't feel like dropping another couple $100 on another full system from retail. I found that I was actually able to obtain a separate base station with keychain remote from eBay for about 70 bucks, I think. So forgive the electrical tape here. This is so I don't actually confuse which one was the victim and which one was the malicious base station. So once I obtained that second system, I was able to configure both systems so that alternately so that they would chime when one of the entry sensors was tripped. I started off with the sensor configured just in one, not the other, set the chime, confirmed, yeah, I heard the tone. Then I configured it in both, and I set off the sensor and confirmed that I heard the chime out of both base stations. So yes, that confirms our hypothesis. The sensors are just doing a very basic broadcast out, and any base station in the area can listen to that sensor and interpret it and integrate it into its own operations. So now we're going to take that hypothesis, we're going to extend it, and we're going to refine it even more. So what else do we know about the system? We know that the base station can be configured to read data from arbitrary sensors now that we've done that test. We also know from the documentation that online monitoring is an optional add-on. So what we're going to do now is we're going to test to see if a physically planted device has usable remote connectivity to pretty much anywhere in the world via the base station's built-in 2G connection. We also know that the system will send monitoring alerts, and so we should be able to build up a pretty robust picture of how that system is used over time. So being a pen tester, this is something that we do when there is a physical aspect to our engagements. I'm not going to go through the details of how I would go through and what I'd be looking for, trends in terms of building usage and things of that nature. But if someone were so inclined, or if this were a penetration test engagement, we absolutely could do a lot of analysis and trending and things like that to determine when, for example, the house or the protected area would be most likely unoccupied, or other attack scenarios. So our next step is to provision online monitoring for the malicious base station to receive these alerts when the sensors are triggered. So I had access to a friendly multi-tenant office, an office in a multi-tenant office building. So I was able to set up the original retail bought SimpliSafe system as it would be deployed in a normal small office sort of environment. As I did that, I also put the malicious base station down in my vehicle in the parking lot. And what I found was that I was able to receive alerts that were delivered to me by email about the comings and goings in that office, even though the base station itself was on a different physical level. It was on a parking lot that was outside of the building. It wasn't even right next to the actual office. So it was a significant distance away. I didn't get all of the sensors, which one would expect. One would hope that the sensor wouldn't penetrate all the way out that way, but certainly enough to give me an idea of when the office was occupied. So now that we know that we have a hypothetical attack that works, what are we going to do to automate that attack and really make it usable in a real-world scenario? So one thing you can do to automate the attack is to run the data capture script as a service in the background on your machine. So that way, really the only limiting factor in the time it takes to do the attack is the time to undo the cap on the remote and plug it into a USB port. Mere seconds. You can either save that configuration off to a file, you can Bluetooth it off to another location. Any means of exfiltration at that point is completely valid. And what else can we do to optimize it for a particular attack scenario? So when you are thinking about these USB keys, there are a couple of different scenarios that pop to mind. Lost and stolen is obviously one aspect of it, but it doesn't even necessarily have to be fully lost. I was going for a run at the gym one day, and I just happened to see one of these sitting on little key hanger things that are outside the front of the building. Why someone would put their keys on one of those in the first place, being a security professional, again, is beyond me, but there are people that do it. And so it got me thinking, well, people do actually give their keys to people for short periods of time, whether it's a valet or a mechanic or, again, on one of those little boards. A lot of times people will leave their keys in the break room at work, and they might not even necessarily know that somebody was able to pick up their keys. I know a number of years ago there was, I guess, an interesting talk about somebody who managed to replicate a physical key with a 3D printer just by taking a picture of it. So this would kind of be the equivalent of that. You can actually run the script easily, very, very easily, on Raspberry Pi Zero. And again, for those that might not be familiar with the Pi Zero, it is a very, very small board, which is actually about the same size as the keychain itself. You can wire that up to a very inexpensive USB power supply. You can oftentimes get them as swag at conventions, or they're given out for free just for promotional materials. So for the cost of $5 for a Pi Zero, an extra flash card you have sitting around, USB OTG cable, you could have an easily concealable method of actually collecting this data. So I did actually reach out to SimpliSafe when I found this vulnerability to do some coordinated disclosure. So they had actually been in contact with me for a couple of months, and they had released a security advisory today. It's available as a blog post up on SimpliSafe's website there, just provided for anybody who wants to check that out. Now, obviously, I think that their recommendations, and my recommendations can disagree a little bit. Reasonable minds can disagree. So I'm told that there's actually going to be a utility that they came out with that's going to help mitigate this problem as well, where customers can actually wipe the configuration off of their keychain remote while they're not making changes. So it would work like this. Basically, you would want to make changes to your system. You would take your keychain remote, you would plug it into the base station. It would write the configuration data to the keychain. You'd plug it into the system, to the laptop, make your changes, and then you'd resync it to the base station. And then you'd run this utility on the laptop again that would reset the data, wipe it off the keychain. Absolutely, for having hardware that was first envisioned and deployed almost 10 years ago, I think that that's a novel way of mitigating the risk. Personally, I think that a lot of users might not want to go through that trouble. I think that a lot of users might forget to do that. I think that having something out there and acknowledging that, hey, yeah, there is a configuration on here, and you do need to take into consideration more than just your base station is a good step. SimpliSafe also did modify some of their guidance to say, hey, if you lose a remote, you should reset your pins just in case. I recommend not using the USB-enabled remote just in case you forget to wipe it. Also, I would recommend if the USB-enabled remote is lost, obviously you can change the pins immediately, but really there's no known remedy to reinitialize the compromised sensor serial numbers. So that kind of makes you think about whether or not, you have to think about your own risk profile, basically. A small business is going to be a different risk profile to somebody who's using this to protect their home. So it might be a good idea to supplement additional security measures, things like web cameras that utilize different technologies, say Wi-Fi or wired connections, or additional locks that might also have notification capabilities as well. So again, yeah, we're pointing out a vulnerability, it's going to be up to the individual to determine whether or not this vulnerability really affects their use case. Finally, I'd just like to mention it's a good idea always to restrict physical access to the base station. It's one of the things where, if you do a little bit of Googling about SimpliSafe, there are some other YouTube attacks out there that you can find on YouTube. I haven't tested them myself. I'm not going to vouch for whether or not they actually are real. But just to be on the safe side, it is a good idea to just sort of keep this in a physically safe spot if you can, if you're going to continue to use the system. So what I've found about the system is that the vulnerabilities that are inherent to the architecture of the system are exploitable in 3 different ways. You can use hardware hacking, you can use SDR and signals analysis, or you can use the native device and abuse of the features that are already built into the system. When you have a secure product and when you are going through and you're inspecting your designs, you're doing risk analysis, it doesn't really matter what the tools are used to attack it. It's a strong architecture. Saying that, well, it's not really a valid attack because they used one skill or they used one particular tool becomes an irrelevant point because you're actually getting to the meat of the problem, you're fixing the root cause. So is the system still useful and effective? And as I said before, that really depends on the individual. So an individual who is looking at high-risk human threat actors, so somebody that has a reason to have a home security system, and it's an unfortunate reality that people out there have stalkers, they have PFAs against people, they know that there are threats that have been made, things of that nature. I'm not sure that I would recommend this system to somebody who knows that there is a high risk of something happening, needing to alert the police quickly. Low and medium risk human threat actors, I'd say that depends on more the use case of, are you looking to protect property? Are you looking to supplement additional controls? It might still be effective on defending against normal smash and grab type burglaries. It might be still useful in deterring there being an incident in the first place. However, it's kind of hard to measure a negative. How do you measure something that doesn't happen? And then there also is the environmental monitoring piece, the environmental threat actors. There's no intelligence, there's no active circumvention of carbon monoxide detector, smoke detectors and water detectors. That's not really my area of expertise. I would leave it to somebody like Underwriters Labs to test those components. They know really what the key variables are and making sure that those systems are effective. So on a high level, what I would say the most apparent vulnerability in the architecture itself is the lack of two-way authentication. So when you have a sensor that is broadcasting out to anybody who will listen, and you have a system that will accept that data without proving integrity or identity, that's really a system that's not able to do some very key things from an information security perspective. You don't have confidentiality, you don't have data integrity, and you don't have data authenticity. When you're building a system like this, you would expect it to have some confidentiality, you'd expect it to have integrity checks, you'd expect it to have authentication checks. So two-way authentication, I think, would be the goal for manufacturers of alarm systems, making sure that you can't just do simple replays, simple spoofs, things of that nature to get around and cause problems, whether it be false positives or false negatives. Does anybody have any questions? All right, well, thank you very much for coming to the talk today. If you're interested in reaching out, there's a couple of different ways you can get a hold of me. I am on LinkedIn. I'm not on Twitter, although my company is. So you can go to the Twitter handle at Spirent Security. You can reach out to me directly at nick.delewski@spirent.com. You can reach out to the whole group at securitylabs@spirent.com. And for anything that's more, of a enthusiast or other sort of email, you can reach out to me. Believe it or not, this actually is a valid email address down there. So did I see a hand over here? And by the way, we do have a couple of shirts, so if you have some questions, feel free to come up and grab a shirt too.
Did you find any attributes in the configuration that were very specific to that particular setup that you had?
Can you speak into the microphone?
Is it even on? Yeah, did you find any attributes in your configuration that were specific to that particular setup?
So,
or unique to that setup?
So a lot of the attributes that I found were pretty common among the other home security systems I've looked at. It was a pretty bare bones configuration, but it is a fairly straightforward embedded system. It's not. No.
I mean, were most of the parameters very generic, or were they particular to that particular setup to recognize each other, the sensor wise?
Oh, they were fairly generic.
They were very generic.
Everything
okay.
was easily set up with just entering the serial number in the config, so you didn't really have to have a whole lot of customization. Were you referring to the testing setup or the actual alarm setup?
The actual alarm setup.
The actual alarm setup, no. Everything is fairly generic.
Oh, yeah?
What I would say is that it wouldn't be interoperable with other systems, but it's not really a complex system.
Okay, yeah, thank you.
Other questions?
So I gave a TorCon talk in 2015 where I used an IMSI catcher to basically analyze the communication between the base station and the actual remote monitoring side.
Okay.
And it just sends unencrypted UDP packets, and then on their back end it's using the base station serial number and the keypad or sensor serial number to actually trigger those alerts. So did you find anything that would let you get the base station serial number from the USB keypad? Or
no.
Anything else?
No, I did not, and I think that would be a key differentiator. Again, the base station serial number would have been a completely different story if you could find that on the device. No, it is not on the device configuration.
All right, cool. Thanks.
Other questions? All right. Thank you very much, everybody. I appreciate your time.